Yeah, my name is Olubenga Shwande, student of Data Telecommunication and Network, and I will be emphasizing on existing solutions to solve congestion control and using a cross-layer approach to solve it. A lot of protocols, algorithms has been proposed to solve congestion, which include TCP feedback, C-cube TCP, ID TCP, RTS validation, and so on and so forth. Now going into cross-layer approach, using cross-layer approach, we could see that when in 1976, when OSI model was being introduced as a standard model for network, wireless environment was not taken into consideration, and the need for a very good layer architecture, building a layer architecture for wireless environment has started. Now, looking at it also, we could see that when the need for this layer to interact, to solve cross-layer, to solve congestion at the cross-layer is needed. I will be going to the next slide to see what was being done. We could see that there's a thin layer that has been introduced between the transport and the network. What is the work of this thin layer? The work of this thin layer is just to act as a tap. When water is flowing into a bucket, when the bucket is almost full, what it does is it sends a negative feedback to the thin layer. And what does the thin layer do? By sensing a negative feedback, it sends information down to the network, to the MAC, back to the sender, which informs the sender that the advertised window and the congestion window should be reduced because congestion has been experienced at the transport layer. And during this process, when congestion happens, it pauses the flow of packets into the transport layer. Now, when congestion has subsided, what happens? It sends a positive feedback to this thin layer to inform the thin layer that I'm ready for more packets to come in. And by doing that, it sends information through the network and the MAC to the sender to tell the sender that increase the advertised window and the congestion window. I'm ready for more packets to come in. And also, by doing that, it increases the performance of the network. Now, one thing we should know is that congestion avoidance, a lot of people have proposed a lot of congestion avoidance like ECN, WinRed, EFFN. They were just for avoidance, but the need to control congestion was the main problem. Also, looking at the MAC layer, congestion also happens at the MAC layer. Using RTS mechanism solve the problem of ED node. But when it comes to force blocking and blocking, we proposed a new protocol called RTS and CTS validation to enhance the problem caused by force blocking and blocking. Now, I will call on my friend to come and finish up. Thanks.
Good morning, everybody. My name is Lenny Jackie, and MSC student of Data Telecommunications and Network. I'm here finally to analyze on what we've discussed so far, myself and my group. It's just a total summary and conclusion of what we've said and done. What have we said? What have we said altogether? My team and I, on the fact-finding surface, has come up with something like this. What is congestion in the real sense of it? This class, assuming, is meant for 30 students. And we have 500 students coming in. Whether you like it or not, the capacity of this class has been overstretched. And whether we like it or not, there must be a drop in some number of students. When we relate it to hard-up wireless networks, when the number of traffic going into the network is more than the capacity, whether we like it or not, packets must be dropped. There must be losses. This will lead to total degradation and total performance of the network at large. What am I trying to say? I did not share. If you ask me to give a verbal index card of what we've done, I must not fail to measure things like MAC, things like TCP, things like buffer, things like bandwidth, throughput, so that we have a total glimpse of what we are trying to talk about. In summary, what have we discussed? That congestion in hard-up wireless network happens as a result of overstretching of the capacity of the network, resulting in the loss of packets and total degradation of network performance. Then we went ahead to discuss the causes of this congestion control. What are actually the causes? Amongst a lot of them, we discuss node defect, we discuss fair blockage, we discuss blockage. And that took us to the general control. Because if we actually know the causes of this problem, we must try and go into a fact-finding survey to get the solutions of these problems we have at hand. Now, we've got a series of solutions that have been proposed because it's still an ongoing research at the end of the day. We've got a whole lot of solutions. Then we finally categorize them under two sub-headings. Which are these headings? It is either you increase the capacity of this network by way of increasing the resources. Resources in this context can be bandwidth, can be buffer space, information body fuel, or you reduce the load. In this context, traffic flow inside the network. These are the two ways. These two subheadings can further be broken down into a lot of proposed solutions, of which amongst a lot of them is the C3 TCP, which my colleague spoke about. Right. After I said that done, we zero in into the fact that C3 TCP is about the most effective so far that have been proposed to solve this problem of congestion network. While we were doing this review and research, what did we eventually learn? What did we eventually come up with? Before now, as an MSc student, I could not actually do a search. I could not do an academic search. I could not do a total review of a research. I could not write an academic report. What have we eventually learned? In summary, we learned about general congestion in hardware wireless network and congestion at large as it relates and applies to general day-to-day life. Like I initially give an example of this class. Having said that, we learned about referencing. At the BSc level, there was nothing like referencing. We got to know of that from this context that yes, this is how to reference, this is how to do it, this is how to analyze this. What did we further learn? We further learned how a team could actually work together. This is a four-man group coming to present and try to be in sync and try to be, it's like a three-legged race. If everybody is not in sync, we'll go astray. So teamwork cannot be overemphasized in the issue of this presentation. So we've come to learn how to work together. Even as engineers, as scientists, as it is, we still learn some managerial acumen as per working together as a team. We learned that. Before now, I was not vast as regards congestion. This presentation has made me know a lot, although the research is still going on about hardware wireless network. And finally, which are the ways that this thing can further improve as per control? If you listen very well to what my colleagues have been talking about all this while, it's all about TCP. Transport layer. TCP is only for transport layer. Is transport layer about the only layer in the OSI? No. OSI starts from physical, data link, network, transport, session, presentation, and community application. This is several layers stuff. Why are we always talking about TCP, that is centered on only transport layer? So we've analyzed that if more research could be done on different layers, centralizing on the protocols in all these layers, we could come up with a better solution other than TCP about the solving of congestion in hardware wireless networks. Thank you very much.
I think it was an excellent presentation, to be honest with you. I enjoyed it very much, and I would like to thank you for putting so much effort in this presentation. I think it is clear that you have worked hard on it, and also that you have worked together to I don't have any basic remark to do except that since you have put the standards very high, probably when you talk, try to not to be on the screen, a little bit away from the screen, so that if people want to read, to be honest with you, I enjoyed listening to you so much that I didn't bother to read myself, but I don't know, maybe others might wish to read what you have written. Otherwise, I think it was an excellent presentation.
Thank you very much.
Thank you.